EcoRoute, our AI-powered solution for carbon-aware compute scheduling built on the Beacon protocol. Data centers consume 200 terawatt-hours annually, yet most workloads ignore the fact that carbon intensity varies by 10 times throughout the day. We're leaving 30 to 40% of carbon savings on the table because there's no bridge between grid flexibility and compute scheduling. EcoRoute solves this with an intelligent BAP agent that uses GPT-4 to pass natural language requests like schedule my AI training with the lowest carbon intensity. The agent sends a discover request to the BAP sandbox, which returns a catalogue of energy windows across the UK, such as Glasgow, Edinburgh, Liverpool, Manchester, etc. Each window includes real-time carbon intensity, renewable energy mix, electricity price, and a time slot. GPT-4 then analyzes all 9 available windows against your optimization priority. For carbon optimization, it might select Glasgow's afternoon slot with 105 grams of CO2 per kilowatt hour and 88% renewable energy. The LLM provides explainable reasoning for every decision. Once selected, the agent executes the complete 7-stage Beacon protocol. Select, init, confirm, status, update, and rating. This all happens asynchronously. The tech stack is production ready. We use Python 3 with LangGraph for state machine orchestration, Pydantic for Beacon RFC validation, and best of all, everything runs on Docker. Our Streamlit dashboard shows it all in real time. You can see past requirements, all 9 grid windows with interactive charts, the LLM's reasoning, complete Beacon protocol flow with transaction IDs, and searchable historical journeys. Now let me show you this live. I'll input a workload request and we'll watch the agent optimize it. I wanted to schedule my AI training job with the lowest carbon intensity. Let me run the agent. The agent is now working. And now the agent has determined the Glasgow window to be the most appropriate. We can confirm this by looking at the grid window. And indeed, yes, Glasgow is the window which has the lowest grams of CO2 per kilowatt hour. Now let's observe the reasoning behind the LLM for this decision. Let's go to the Decisions tab. And as you can see, the LLM's decision reasoning is as follows. The Glasgow afternoon window, etc., etc., etc. But if we were to run the same problem statement again with the agent, will it have the same reasoning? I don't know, let's check. I'm running the agent again. The agent is working. And as you can see, the decision completely remained the same, but its reasoning, the output, has completely changed. So the LLM is actually making its own decision based on the information that's available to it. We can see the transaction ID, stages complete, such as all the API endpoints that have been hit, and of course other information related to the requests. In this case, our transaction ID is as follows: internal order, etc. The history tab is more of a log of all the executions run by the agent. For example, the one we executed earlier on, schedule my AI training job, the lowest carbon intensity, for which the Glasgow window was selected. And of course below, we have the reasoning for every single one.